Welcome friends, this is my third video on the topic differentiation for class 12 students. In the last video, we discussed chain rule. We stated the rule and also we proved it. In this video, we shall see some corollaries on the chain rule, and after that we shall solve some examples on the chain rule of differentiation. Now what is chain rule? Chain rule says that if y is a differentiable function of u and u is a differentiable function of x, then dy by dx is equal to dy by du into du by dx. dy by dx is equal to dy by du into du by dx. We can understand this rule better by solving some examples. We can take some illustrative examples in the beginning, then we shall see some other examples also. So let us see one example. Consider this example. Find dy by dx if y is equal to log x, y is equal to log of sin x. Now look at the function log of sin x. That has to be differentiated with respect to x, but before that we have to consider this log of sin x, which is a function of sin x, and then sin x is a function of x. The log of sin x, which is y, is a function of sin x, which is u, and sin x, which is u, is a differential function of x. That's how we compare this situation with the rules format. Now u is taken equal to sin x. U is sin x. Therefore, differentiating with respect to x, I will get du by dx is equal to, du by dx means derivative of u with respect to x, which is d by dx of u. U is sin x. Now d by dx of sin x is equal to cos x. So du by dx is equal to cos x. Now we have found du by dx. Du by dx is found. We have to find out dy by du. So what is y? Y is equal to log of sin x, which is equal to, see, log of sin x. Y is equal to log of sin x, which is equal to log of, what is sin x? Sin x is u. We have considered sin x as u. Therefore y is now log of u. So differentiating y is equal to log of u with respect to u, I will get dy by du. So dy by du means differentiating with respect to u, I get d by du of, what is your y? Dy by du means d by du of y. What is y? Y is this, or even you can consider log of u. So dy by du is d by du of y, which is d by du of log u, which is equal to, you must know this, just like d by dx of log x is 1 upon x, d by dy of log y will be 1 upon y, d by du of log u will be 1 upon u. So it will be just 1 upon u. And once we find dy by du, we can get back to our original value of y. U is sin x. So right here u means sin x. So it will become 1 upon sin x. You may write it as cosec x also if you want. You can leave it as it is. That is not important. Then we have found out dy by du also. Earlier we found du by dx also. So both of them are found. So we can take product of them and get dy by dx. So by that rule, dy by dx is equal to dy by du means, okay, dy by du into du by dx, which is equal to dy by du's value 1 upon sin x into du by dx's value. Du by dx is found equal to cos x, and you can finish this as 1 upon sin x into cos x, means you can write it as cot x also. So dy by dx is equal to cot x. That's how we can find this answer. Let's revise it quickly. Our function was y is equal to log of sin x. We wanted to differentiate this and get dy by dx. We wanted to differentiate it with respect to x so that we can get dy by dx. So dy by dx was the question asked. So what we did is took y is equal to log of sin x and understood it better as log of sin x is a function of sin x and sin x is a function of x. So you can understand what is u. So u is found out equal to sin x. Now we took this u in the beginning because we had to find out du by dx. So we took u is equal to sin x in the beginning. Actually this is the rough step. This is the rough step. You should remember this whole thing has to be done in mind. So just I am highlighting that. You can do it in rough also. In the rough, on the rough page somewhere you can write it, and then your answer starts from here. U is equal to sin x. Therefore we differentiated u with respect to x to get du by dx, which is d by dx of u, which is d by dx of sin x. Now d by dx of sin x is very easily known. It is cos x. It's a ready example. Then once we find du by dx, our this part is completed. We have to find out dy by du. So we have to take y first of all. What is our y? Y is given there, log of sin x, which is y. Log of sin x is y, but then sin x is assumed to be u by s. We have in the beginning we assumed u as sin x. So sin x is replaced by u and it will become log of u. So y is log of u. Now once y is log of u, you can differentiate y with respect to u, dy by du. That means d by du of y. What is y? D by du of y is log u. And log u derivative with respect to u is 1 upon u. 1 upon u in the end we can write it as 1 upon sin x because u means sin x. Now after finding du by dx and dy by dx, which is actually just 1 upon sin x is important. This part is just some part which we require to complete before getting the final form. So dy by du is equal to 1 upon sin x and du by dx is equal to cos x. See this highlighted part. Put these two things in this formula which is there and get dy by du's value 1 upon sin x and du by dx's value cos x. Just you can simplify this and get cot x. Let us consider some other example. Number 2 example. Y is equal to tan of 2 raised to x. And we will find out dy by dx. We have to find out dy by dx when y is given equal to tan of 2 raised to x. See, tan of 2 raised to x is not a standard function. What is standard function? Standard functions means the functions of x. So tan of 2 raised to x is not a function of x. Tan of 2 raised to x is a function of 2 raised to x. And then 2 raised to x is the function of x. Similarly, log of sin x. Earlier we saw. Log of sin x is the function of sin x and then sin x is the function of x. Tan of root x. Tan of root x is the function of root x and then root x is the function of x. Or root of sin x. Root of sin x is the function of sin x and then sin x is the function of x. You can go through these kind of examples to understand the composite functions. These are all composite functions. We are now discussing only composite functions and their derivatives are found by using chain rule. So let's come back to this example. Y is equal to tan of 2 raised to x. Dy by dx has to be found out. So what we do in rough is, like I discussed in the last example, I will take this tan of 2 raised to x, that's our given function, which is a function of 2 raised to x, and then 2 raised to x is a function of x. So how does the chain work? This tan of 2 raised to x is y, this 2 raised to x is u, and that is x. So y is the differential function of u and u is the differential function of x. Then dy by dx we know is, as we stated earlier, dy by dx is equal to dy by dx is equal to dy by du into du by dx. We remember that rule as chain rule. Let us use this. We shall see the rule applied like this. So answer starts with our assumption of u is equal to 2 raised to x. We assume this. So let u is equal to 2 raised to x. Therefore, differentiating with respect to x, you have to write that there, differentiating with respect to x, while solving the example in the exams. You have to mention that differentiating with respect to x. I am just orally saying that and then moving ahead. Differentiating u with respect to x, I will get du by dx is equal to d by dx of 2 raised to x. d by dx of 2 raised to x is, d by dx of 2 raised to x is found by, you have to remember this rule, d by dx of a raised to x is a raised to x log a, exponential functions formula. So d by dx of 2 raised to x is 2 raised to x log 2. We have found du by dx as 2 raised to x log 2. What you have to find more is dy by du. You should remember this rule, chain rule. Chain rule states dy by dx is equal to dy by du into du by dx. After that du by dx is found, and we have to find out dy by du. So consider that y. What is y? Y is equal to tan of 2 raised to x. Tan of 2 raised to x means what? Tan of 2 raised to x is u. So tan of u only. Now I have y is equal to tan of u. Earlier we wrote y is equal to tan of 2 raised to x, but 2 raised to x is taken as u, so I read y is equal to, therefore dy by du, which you have to find, is d by du of y. Y is d by du of y is this or even this. So we write that tan u and y. Now what is this? D by du of tan u is just like d by dx of tan x. D by dx of tan x is sec square x. So just like that, d by du of tan u is sec square u. Now after completing dy by du, what you have to do is get back to your original form of u. U was 2 raised to x. So we can write this as sec square. What is u? 2 raised to x. So that finishes dy by du. Earlier we found du by dx. So what was du by dx? It's 2 raised to x log 2. Then we found dy by dx. Dy by dx, earlier found du by dx. Now we found dy by du as sec square 2 raised to x. So we can use this du by dx and dy by du to finally write dy by dx, therefore equal to, therefore chain rule is applied here. Dy by dx is equal to dy by du into du by dx, which is equal to, what is dy by du? Sec square 2 raised to x into, what is du by dx? Du by dx is 2 raised to x log 2. You can leave it as it is only. Sec square 2 raised to x multiplied by 2 raised to x log 2. This is your dy by dx in the end. So see the answer once again. Your function was y is equal to tan of 2 raised to x, and we wanted to find out dy by dx. What did we do? We took u as 2 raised to x. Then we found du by dx, because in chain rule you require du by dx and dy by du. So we tried to find du by dx in the beginning. It is equal to 2 raised to x log 2. Then we found dy by du. It is equal to sec square 2 raised to x. Then we use them together to find dy by dx. Consider this another example. Y is equal to log of tan of root x. Now we have to imagine the chain. This is the rough work I am doing here. See, log of tan of root x is a function of, log of tan of root x is a function of tan of root x. Tan of root x is a function of, tan of root x is a function of root x, and root x is a function of x. Can you imagine this chain? See, log of tan of root x is a function of tan root x. Tan root x is a function of root x, and root x then is a function of x. So this is y is a function of u. U is a function of v, and v is then finally a function of x. This is that another example where we have to extend the chain rule which we have studied so far. We have studied it as y is the differential function of u and u is the differential function of x. Then dy by dx is equal to dy by du into du by dx. But if it is y is the differential function of u and u is the differential function of v and then v is the differential function of x, then dy by dx is equal to, go through chain like this, dy by du into du by dv into dv by dx. So how do you write dy by dx in this case? Dy by dx is equal to dy by du into du by dv into dv by dx. So this is that example where you require to extend the chain rule to 3 steps. Now if you have suppose 4 functions like this, means y is the differential function of u is the differential function of v is the differential function of w, and then w is the differential function of x. Then you can write d by dx, means dy by dx as dy by du into du by dv into dv by dw and then into dw by dx. So you can generalize this, and if you have y is the differential function of u1 is the differential function of u2 is the differentiable function of u3, and this goes on. Finally un is the differential function of x. Then so y is the differential function of u1 is the differentiable function of u2 is the differential function of u3 u3 is the differential function of u4, and so on. And then finally you have un differential function of x. Then dy by dx directly is written as dy by dx in that case is equal to dy by du1 into du1 by dy by du1 into du1 by du2 into du2 by du3, that will go on, and then finally into dun by dx. You can understand this extension of chain rule easily. We can start with the initial form dy by dx as dy by du into du by dx. We saw it for 3 functions, means two u and v functions, and y the original one. Dy by dx is equal to dy by du into du by dv into dv by dx, and you can extend it to any number of intermediate functions, and you will get dy by dx as dy by du1 into du1 by du2 into du2 by du3 and so on, finally dun by dux. Let us use this in this example and try to find out how. So see this example once again. Y is equal to log of tan of root x, and we saw this chain as log of tan of root x is y is a function of tan root x, which is u, is a function of root x, which is v, and then finally v is a function of, means root x is a function of x. So let us start with the rule which I'll use is dy by dx is equal to dy by du into du by dv into dv by dx. So in the beginning I have to find out dv by dx, then du by dv, then dy by du, and finally you will get the final one. So let us see dv by dx. For that I have to write v. What is our v? dv by dx is to be found out, so I have to take v first. What is v? v is root x. v is root x. So differentiating this with respect to x, because I want dv by dx. So v will give me dv by dx after differentiating it with respect to x. So dv by dx is found by differentiating v with respect to x. That means dv by dx is equal to d by dx of v, which is root x. d by dx of root x is, you must remember this is direct formula, d by dx of root x is 1 upon 2 root x. So dv by dx is found 1 upon 2 root x. Let's find out du by dv. For that I have to write what is our u. What is our u? U is equal to, what is u? U is equal to tan of root x. Tan of root x. U is equal to tan of root x. So I can get du by dv by different, means first of all du by dv is to be found out. So I have to write tan of root x in terms of v. Tan of root x in terms of v is written as tan of, what is root x? Root x is v. So tan of root x means tan of v. Now consider u as just tan v. Now read u equal to tan v instead of tan root x being taken as v. So tan root x becomes tan v. So u is tan v. So differentiating u with respect to v, du by dv, because I have to get du by dv. So I have to differentiate u with respect to v. So du by dv is equal to d by dv of u, which is tan v. D by dv of tan v. Here the question comes as d by dx of tan x is sec square x. So d by dx of tan x is sec square x. D by dv of tan v will be sec square v. Once you find that derivative, you can get back to your original form. What was v? V was, I shall repeat this, sec square. V is root x. Sec square root x. So du by dv is found out. Du by dv is equal to sec square root x. Du by dv is found out. Now we have to find out dy by du. For that I have to write y first. Now y has to be written in terms of u. So y originally is log of tan of root x. Log of tan of root x, which is equal to log of tan of root x is, so directly we can write this. Log of tan of root x can be directly written as, see what is tan of root x? Tan of root x is u. So log of u. Remember this, see y is equal to log of tan of root x, but tan of root x is log u because we want dy by du. So I have to express y in terms of u. So I have expressed y in terms of u, and I have found y is equal to log of u. Therefore, differentiating with respect to u, I get dy by du is equal to d by du of log u. D by du of log u. Just like d by dx of log x is 1 upon x, d by du of log u is 1 upon u. And 1 upon u in the end is written as 1 upon u. What is your u? U is tan root x. So 1 upon tan root x. So far we found dv by dx. See here, dv by dx is 1 upon 2 root x. dv by dx is 1 upon 2 root x. Then we found du by dv. Du by dv it is equal to sec square root x. Then we found dy by du. dy by du is equal to 1 upon tan root x. And now we shall just put these values in the formula to find out the final answer. Dy by dx as dy by dx is equal to, write dy by du in the beginning, 1 upon tan root x multiplied by du by dv. Du by dv is equal to sec square root x multiplied by dv by dx, which is initially found 1 upon 2 root x. 1 upon 2 root x. So we can finish it as sec square root x upon tan root x into 2 root x. 2 root x can be written in the another bracket also. So this is dy by dx. See the whole example. This was a 3-link chain. We had log of tan root x, which is a function of tan root x. Tan root x is a function of root x, and then root x is a function of x. So we wanted to find out dy by dx. It can be found as dy by du into du by dv into dv by dx. So you begin with dv by dx. For that you have to take v. So v was taken as root x, and then it was differentiated to find dv by dx. Then you have to get du by dv. For that you have to take u in terms of v. U is written here, but then it is expressed in terms of v, and then it is differentiated with respect to v to get du by dv as initially in terms of v, then we have to come back in terms of x. Then we have to get dy by du. For that you have to express y in terms of u. Y in terms of u is written here. Originally y is log of tan of root x, which is written in terms of u as log of u. Then we can differentiate it with respect to u and get dy by du as 1 upon u, but then we have to write it in terms of x as 1 upon tan root x. And then after finding these three, we can put them in the chain rules formula. This is the rough work. You can imagine this and then finish it like this. This is one method of using chain rule. We solved 2 or 3 examples using that method. This method becomes a little bit tedious when the chain becomes a little bit longer. So as long as the examples are simple, we can use this method. But as soon as the examples contain more functions, for example, the example which we saw lastly, it was log of tan of root x, etc. Or you can have log of sine of root x. Then assuming the functions u's and v's, etc., it becomes a little bit lengthy and even tedious. So there is another method. There is another method which can be used to solve such examples, and that we shall discuss in the next video.